Hello my friends and welcome to the final practical activity of this course. Yes, I must start by saying that I'm at the same time excited but sad that this is the end of the journey, but no worries, we're going to end on a very, very good note. And that good note is about, of course, XGBoost. It is a super powerful machine learning model which I absolutely want you to have in the toolkit, because you will see that it brings excellent results in most machine learning problems. And actually, the thing so cool about this is that it can be both used for regression and classification. So there we go. Let's cross the finish line together in this final tutorial by implementing the XGBoost model. So that model is given to you in part 10. So just before we enter this part, make sure to be on that same page. I give you the link to this folder right before this tutorial in the article, so make sure to connect to it. And now here we go. Let's finish this journey together by entering part 10 and then the final section of this course, section 49 on XGBoost. All right, and as usual, we're going to start with Python, which contains two files. First, the data, and second, the implementation. And now, you probably also noticed that there are many files open now on my machine, right? All these files. And these are, the files that we implemented so quickly and efficiently when doing that model selection demo at the end of part 3 classification, right? I gave you this model selection folder with all these classification models which were experimented on the same dataset, which is that dataset, data.csv, and which I remind consists of predicting if a breast cancer tumor is benign or malignant, meaning that each row of this dataset corresponds to a patient, it's a certain patient, and for each of these patients we have several features, from the clump thickness, the uniformity of cell size, the uniformity of cell shape, all these features that are characteristics of a tumor. And with all these features, we were trying to predict if the tumor is benign or malignant. It is benign if we get the class 2 and malignant if we get the class 4. All right? And we built and trained all of our classification models, which are all the ones right here, to learn the correlations between all these features and that dependent variable telling if the tumor is benign or malignant. And remember that we had different accuracies for each of these models. With the logistic regression model, we had an accuracy of 94.7%. With the k-nearest neighbors, we had an accuracy of 94.7% again. With the SVM, we had an accuracy of 94.1%. With the kernel SVM, we had a better accuracy actually with 95.3%. With naive Bayes, we got a lower accuracy of 94.1% again. And with decision tree classification, well, that was the winner. We got an amazing accuracy of 95.9%. That was the number one on the podium, followed by the kernel SVM with that accuracy. And then, unfortunately, Random Forest did not do any good, or, not better than the others, because we got a 93.5% accuracy with it. And so, what I want to do now, as you probably have guessed, is to build the XGBoost model and train it on the same dataset to see if it can take the throne held by the decision tree classification model. In other words, to see if it can beat that accuracy obtained with the decision tree classification model. And well, maybe that's the good note on which we will end the journey of this course. Are you ready? So let's do this. We're now going to build and train our XGBoost model on the exact same dataset and see if we can beat basically an accuracy of 95.9%. And not only we will test that on a single test set, but also, of course, now that we learned k-fold cross-validation in the previous section, we will test this on 10 test folds so that we can get a relevant measure of the accuracy and make sure that perhaps XGBoost will now become the number one on the podium with the ultimate machine learning throne. So let's check this out right now. Let's open this implementation with either Google Collaboratory or Jupyter Notebook. I'm going to put it last, just next to all our other classification models. And Now the notebook just opened, but it is still in read-only mode, so we're going to create a copy right away by clicking Save a Copy in Drive. You can notice that all these are copies of the original implementations, which are right here. You know, that's the model selection folder and then classification subfolder, which I gave you at the end of part 3. So you can run these codes again if you want, but we already did that. Just remember that the number 1 was indeed decision tree classification with an accuracy of 95.9%. And now we're going to see if we can beat this with XGBoost. All right, so of course, no worries, we won't re-implement all this. We will quickly get to the core of the implementation and mostly the exciting part, which are the results in this same tutorial, because indeed all the cells of this implementation are just cells taken from our diverse toolkit, right? These 3 first cells are, as you recognize perfectly, the cells of our data preprocessing template, right? We first import the libraries, then we import the dataset with the exact same code. I just put the name of the dataset here, and then we split the datasets into the training set and test set. So this is all the data preprocessing phase. Then we train XGBoost on the training set, and of course I'm going to delete this cell right away because that's the cell we will re-implement together. And then we have the other tools of our other toolkits, like the classification toolkit, because indeed this cell makes the confusion matrix and prints at the same time the accuracy. I actually already deleted the output to make sure we get the full surprise by the end of this tutorial. And then, of course, as I told you, we are going to apply k-fold cross-validation right at the end to make sure that indeed we didn't get lucky on the test set, you know, if we indeed can beat all the other algorithms. So we will not only get a first measure of the performance thanks to a single test set with this cell, and then we'll get the ultimate measure of the accuracy with that cell. Are you ready? Let's start by building and training XGBoost on the training set, which resulted from the split of the dataset between the training set and test set. And first, in order to get the assistance of Google Colab, well, let's apply this reflex of uploading the data into the notebook. So, you know, I just clicked this folder button here, and in a second we'll see the upload button to upload indeed our dataset. So let's click it. And now let's go to our machine learning A to Z codes and datasets folder, because you will still find the data.csv file in this folder in part 10, of course. So let's go into this folder, then let's go into part 10, then section 49 XGBoost, Python, and here is the dataset data.csv of many patients with tumors for which we have to predict if the tumor is benign or malignant. So open, okay, and now the dataset is indeed uploaded into the notebook. So there we go, we can implement that cell and then run the whole code. All right, so let's create a new code cell, and there we go. Let's build and train XGBoost on the training set. So you're gonna see that it's going to be super easy, and in fact we won't even do it with Scikit-Learn, but with a library called XGBoost, and which we don't even have to install thanks to Google Colab, because it is one of the many packages already installed on Google Colab, you know, already pre-installed, so we have nothing to worry about, and we can just start building and training this XGBoost model. But first we're going to import the class with which we're going to build this, and this class belongs of course to this XGBoost library. So there we go, we're going to start from this XGBoost library, right? It's spelled this way, just like the name of the model, XGBoost indeed. And from this library, we're going to import, well, the class that can build an XGBoost classification model, and which is called XGB. There we go, Google Colab found it, XGB classifier. All right, and now the next natural step, as usual, is to create an instance of this class, which will be exactly the object containing the XGBoost model. So once again, we're going to call it classifier. All right, and we'll create this classifier as an instance indeed of the XGB classifier class. Perfect. And now the good news is that we won't have too much to worry about with this class, because there is not much parameter to tune, right? Basically the default version of the XGBoost model will most of the time perform super well, so all good here. And now, of course, we finished this by connecting this XGBoost classifier to our training set. And the way to do this is by, of course, calling the fit method from our classifier object, which will do nothing else than train this XGBoost classifier on the training set, right? So something we did many times. So there we go. Let's do it one last time in this whole machine learning journey, but then I'm sure you will do it many times once again in the future, in your future machine learning career. So let's do this. We call our classifier, from which we're going to call this fit method, which will train the classifier on the training set, which is composed of first the features of the training set represented by xtrain, and then the dependent variable of the training set represented by ytrain. And these are exactly, of course, the inputs of the fit method. All right, so in the flashiest of the flashes, we built and trained this XGBoost model on the training set. We only had to implement these 3 lines of code, and then all the rest is something we've already done. You know, this is the confusion matrix. You have this code in all of your classification templates. And finally, of course, we apply the exact same cell that we implemented just before in the previous section to apply K4 cross-validation. So we're ready to run this code, but just before we do it, I just want to show you the way to build an XGB regressor model, you know, an XGBoost model for regression. It's actually super simple. The only thing you will need to change here is just, of course, the name of the class, which wouldn't be XGB classifier, but XGB. And as you will see, XGB regressor. And then, you know, you would just replace classifier here by regressor. And then that's it. This way you will build a regression model based on XGBoost. All right, but let's go back to our XGB classifier class, and there we go. Now we can just save this implementation and do a run all to find out if XGBoost is going to steal the throne of the decision tree classification model for this particular dataset. So quick reminder, with the decision tree classification model, we got the best accuracy, you know, the highest one of 95.9%. And now let's find out if we can beat this with the XGBoost model trained on the exact same dataset. All right, so basically we're ready now. We're just gonna do a run all by clicking runtime here. And now, are you ready? I bet you are. So let's do this. 3, 2, 1, go. All right, so all the cells are running now, and we get an impressive accuracy of 97.8%. When I was telling you that we're gonna end this journey on a good note, well, I was choosing my words very, very carefully. Indeed, that's just an amazing accuracy. You know, there are only 3 incorrect predictions on such a sensitive problem, you know, cancer prediction. Well, this result is just amazing. Here, indeed, we almost get 98% accuracy with these only 3 incorrect predictions. That's just amazing. But now we have to check one last thing, because, you know, maybe we got lucky on this single test set. Maybe that single test set was more favorable to XGBoost than the other classification models, which could explain why XGBoost was number 1. And the only way to check this is by actually computing other accuracies on other test sets. And this is exactly what K4 cross-validation is about. And that is why this is the last cell of this implementation. And we also have the result for this, which is, as we can see, still an amazing accuracy of 96.53%. This is, of course, an average accuracy obtained as a result of the average of 10 different accuracies measured on 10 different test sets. And besides, we have a rather small standard deviation of only 2%, which is good, once again, for this sensitive problem of cancer prediction. So yes, XGBoost is definitely number 1 here, and that's why, my friends, I'm just super happy that we end on this good note with this final powerful tool that you get in your machine learning toolkit, because now you can start your post-machine learning journey, you know, for your career in full confidence. And about that, that will be my final words to you in this course. I wish you tons of great success in your future machine learning project. I wish that you are the talented data scientist who brings the strongest insights and the highest value analysis to your team and to your clients. Now you're totally able to do this thanks to your complete and powerful machine learning toolkit. With these, you're totally able to smash your future machine learning problems. So once again, I wish you the best, and I look forward to seeing you in another course for a new data science journey. And until then, of course, enjoy machine learning.